Hello students, welcome to the class. We started with our laws of motion chapter. So till now we discussed Newton's laws and examples and other related terms to the first law, second law and third law. These all concepts are over already. We discussed about momentum, right? Conservation of momentum and the expression for conservation of momentum. We saw the example where this conservation of momentum is applicable in our day-to-day life. And then next, we discussed the concept called as friction, correct? So in the last class, we discussed about friction also, right? So what do you mean by friction? We know friction is nothing but what? It is the opposing force. Friction is nothing but what? It is the opposing force. Whenever any body is moving in the forward direction, there will be one force which acts in the opposite direction. So that force is nothing but what? Friction here. So this friction is proportional, and it is proportional to the normal force. Whatever the frictional force is there, it is always proportional to the normal force on the body. Okay, and it depends on the, here we discussed about the laws of frictions. So in the laws of frictions, we saw that here the body experiences whatever the frictional force, it depends on the nature of the surface. Always the frictional force acts when two bodies are in contact with each other. Then the frictional force acts, right? Here, whatever the frictional force is acting between the two bodies, it depends on the nature of the material or the nature of the surface. But it is always independent of the area in which it is in contact. Right, we discussed about the types of friction. So in the types of friction, here we discussed kinetic friction, then static friction, rolling friction and sliding friction. So in all these types, we have seen what are the example. So how it works: kinetic friction, static friction, rolling friction and sliding friction. So these all concepts we covered in the last class. Also we covered, that is, when an object is, or when a body is in a lift. Here, four different conditions we have discussed. So when it is moving downward, or when it is moving upward, or when it is moving with a constant velocity, or if it is freely falling. So what is the expression for the force which is acting on the body that we discussed, right? So today we are going to see the methods to reduce the friction, what are the advantages, disadvantages, right? And the uses of friction here. Okay, so this reduced friction, how to reduce the friction also we discussed few points. So just we'll see what it is, how we can reduce the friction. We can reduce the friction. There are 4-5 methods are there. First, we can make that is whatever the boats, planes, car, all these vehicles or all these devices, when it is moving, here the frictional force acts on it. Okay, so to avoid that, the designs of the car, plane, boats are made in such a way that it is easy to move in the that fluid friction, right? We can use the polishing, that is polishing the surface can reduce the friction. Then we can use the lubricants like oil, grease, paints and all. Then we have, that is, when the objects are rolling over the surface, there we can use this ball bearings. There we can use the ball bearings. These are the methods how we can reduce the friction. Okay, then next, so next we have applications of friction. So what are the applications of friction here? See here students, what are the applications here? Application is, we are going to discuss that this friction help us to walk. See, we are all walking on the floor or road anywhere. Here, the because of the friction, this is possible. Suppose if there is a floor on which that is a complete water is there. So what happens when you move on that, here you will slip on the floor. That is because of what? Here friction is reduced. So you are able to walk properly, or a balanced walk is possible. That is only because of what? Only because of friction here. So friction helps us to walk. Second, we can write on paper or on boards using a pencil or chalk. So we are able to write on board or any book or anywhere. That is also because of what? Friction between the paper and the pencil, or friction between the board and the chalk. So because of this reason, a person is able to write. So if the frictional force is not there between these two, again the writing is also not possible. So here, so normal walking is also not possible, then normal writing is also not possible. So if friction is there, these two phenomena are not possible. Then the third point, the friction between the material and the atmosphere heats it up and it makes it burn and shrink in size due to air resistance. See here in our atmosphere also the friction is taking place. So because of that reason, whatever the our surrounding is there, it heats up. It heats up, they are saying, okay. Right? So this is because of what? This is because of, that is friction, the friction between the meteor and the atmosphere. It heats up and makes it burn and the shrink in size due to air resistance. So due to air resistance, this phenomena takes place. That is meteor phenomena takes place. Okay. Next point. We can fix a nail to the wall. So suppose if you are fixing a nail to the wall, there also this friction is applicable. The friction between the nail and the wall makes the nail to fix it on that. Next point, brakes in vehicles are built on the concept of friction. So here how brakes in a vehicles are built on the concept of friction. This is also built on the concept of friction here. Next point, pulleys for drawing water from wells work with the help of friction. So here pulleys. So I hope you might have seen the wells, on the wells to lift the water with the help of that container and all what we are using. So pulleys will be there. So the friction between that pulley and the rope makes us to lift the water. So that is drawing the water from the wells. That is also because of friction. Then next point is friction is used for making fire by rubbing wood on wood or stone on stone. So earlier days, means in our ancient time, we used to rub stones and we used to get the fire. So nowadays we have a matchbox. So there also the frictional phenomena we can observe. Correct. So these are what application of friction. See, as students, in our day-to-day life, whatever the phenomena we are observing, that is all because of this friction. That is walking, writing, then fixing the nail to the wall, then brakes in a vehicles, pulleys, then get that is a fire by rubbing the wood or stone and stone on stone. So these are what advantage, that is applications of friction. Okay. Then, so next we can see what are the advantages of friction. So application and advantages, it is almost same concept only we can consider. That is advantages of friction. What are the advantages here? See, friction is responsible for many types of motion. So what do we are saying? That is friction is possible. Friction is possible only because of, sorry, motion is possible, that is only because of the friction. If the friction is not there, then motion is very difficult. Okay. Then next, it helps us to walk on the ground. Brakes in a car make use of friction to stop the car. Asteroids are burnt in the atmosphere before reaching Earth due to the friction. It helps in a generation of heat when we rub our hand. So when you rub your hand, when you are rubbing your hand, here what happens? Whatever the heat is generated, there it will make the make the palms warm. So this is also because of friction phenomena. So here you can see That is advantages of friction. So walking, writing, fixing a nail, application and advantages, it is almost same only, we can say. Okay. So the main thing is what we need to understand is friction is, that is motion of a body, is not at all possible without friction. Right. And you can consider that is if the vehicles are moving, the wheels and the surface or the ground will also experience the friction. So vehicles are also easily, it is possible for the vehicles also to move easily. That is also because of friction itself. So these are what advantages of friction. These are the advantages of friction. Then next, disadvantages of friction. So what are the disadvantages of friction? See here, friction produces unnecessary heat leading to the wastage of energy. So what they are saying here, due to the friction, see, you can assume that whatever your vehicles are there, here in the engine, the heat is produced. The friction between the engine parts, due to that, the heat is produced. So here, due to that heat, here what happens? A wastage of energy is taking place. Okay. So whenever the unnecessary friction is produced between the engines or anywhere, here energy is wasted. So this is the main disadvantage of friction. Other disadvantages are the force of friction acts in the opposite direction of motion. So friction slows down the motion of moving objects. See here, always this frictional force, I told you, it is opposite to the direction of the applied force. So because of that reason, here what happens, whenever any object is moving, if you want to slow down, you need to apply the friction here. Here what happens means, how much you require, that much only you will apply, no doubt. Only the thing is what, the vehicle or the moving objects, the speed will be reduced by using the friction. It is a type of advantage also, it is a type of disadvantage also. Okay. Next point is forest fires are caused due to the friction between the tree branches. So it is the most disadvantage part of friction. That is the friction between the branches in a forest. What happens here? The fire, the that tree will catch the fire here. Okay. Then next point. A lot of money goes into preventing friction, and the usual wear and tear caused by it using techniques like greasing and oiling. Here, to reduce the friction, means to avoid the friction, we need to spend little money. Okay. So here we need to grease it, we need to do regularly oiling of the machines and engines and all. So this is a kind of disadvantage. It is a kind of what? Disadvantage of a friction. Okay. So here, as I told you in the first point, that is waste of energy takes place. So whenever the waste of energy takes place, what happens to the engine life here? Here the efficiency, I hope you know the word efficiency. So efficiency of the vehicles or the machines decreases due to this waste of heat or waste of energy. Okay. So these are what disadvantages of friction. So wear and tear takes place, waste of energy takes place. The friction will reduce the speed. Then here the tree branches will catch the fire. The efficiency of the engine reduces. These are all called as disadvantages of friction. So advantages, disadvantages. Here whatever our application is there, we can consider application and advantage part same or similar. Okay. Therefore, as this friction is having both advantage and disadvantage, we call this frictional force or the friction as evil to the nature. Okay. So evil means what? Which is both having some advantages, having some disadvantages also. Right. So this is what the friction, its advantage, disadvantage and application. Okay. So if we are clear with the friction and its then the advantage disadvantage part. Next, let us go for some of the definitions which is related to the friction itself. So first here we are going to define angle of friction. So what is angle of friction? See here, angle of friction is defined as the angle made by the resultant of frictional force and the normal reaction. So here this angle of friction is nothing but it is the angle between, it is the angle between the frictional force. So frictional force is in the opposite direction and the normal force here you can see in the figure, it is in the above direction. So where whatever the angle is created between them, it is called as what? That is angle of friction. So in the picture, once again, I'll just show you where it is. Here you can see, oh, sorry. See the students, that is, it is the angle made by the resultant of frictional force. So this is the applied force, this direction. Okay, applied force. Frictional force is what? It is always opposite to that. So this is your frictional force. Here you can see the resultant. Here you can see the resultant of frictional force and the normal reaction and the normal reaction. So this angle we call it as what? That is angle of friction. This angle we call it as what? Angle of friction. So here we have one expression also. You can see that from the triangle LAC. You can see here from this triangle. That is, here your L is there. Okay. So here this is LAC. So this is LAC triangle. So from this triangle, tan alpha is equal to, so tan alpha is equal to what we can just write, that is P divided by B. We can write it as P divided by B here. That is nothing but AL divided by, that is nothing but AL divided by AC. AL divided by AC. So AL is nothing but what? It is F. It is the force F, and AC is nothing but the normal reaction, that is R. Therefore, we know that mu is equal to F by R. Therefore, tan alpha is equal to, we can only write it as mu. Tan alpha is equal to, we can write it as mu. So this is what? Angle of friction. We should know what is angle of friction, how it is denoted, right? Next definition, which is related to friction again, that is angle of repose. So what is angle of repose here? Angle of repose is the maximum slope angle of non-cohesive. So still here students, what is non-cohesive? It is a free flowing, okay, which means non-cohesive means there is no attraction, that is non-cohesive. So free flowing it is granular materials, granular materials, okay. It is the angle between a horizontal plane and the cone slope of such a material is called as what? Angle of repose. It is called as angle of repose. Or you can also define it as, it is the minimum angle made by the inclined plane with the horizontal surface such that the body lying on the inclined plane is just at the verge of sliding down along the inclined plane, is called as what? Angle of repose. Angle of repose, right? So this angle of repose also we have the expression. If you want that I'll tell you, means from the figure I can explain you the definition. See here. That is, suppose this is the horizontal plane and This is the inclined plane. Here the angle alpha will be there. Okay, so see that it is the minimum angle made by the inclined plane with the horizontal surface such that the body lying on the inclined plane is just at the verge of sliding down along the inclined plane. Means suppose on this inclined plane, suppose if the vehicle or some object is there somewhere here. This is called as what? This is called as the object is just at the verge of sliding down along the inclined plane. So now here, whatever the angle it is creating, that is called as angle of repose. That is called as angle of repose. Okay. Getting? So angle of friction, angle of repose. Either you can say it as a maximum slope, angle of non-cohesive granular material, or it is one more definition down it is written. It is the angle it is a minimum angle with the horizontal and the inclined plane. So that is also called as what? Angle of repose. Angle of repose, right? So next point. So what is the application of this angle of repose? See here, students. The angle of repose is sometimes used in the design of equipment for the processing of particulate solids. For example, it may be used to design an appropriate hopper or a silo to store the material, or to size a conveyor belt for transporting the material. So in all these processes, we are using the help of angle of repose. So if you understand the angle of repose concept, then these all phenomena will be easy. Okay, it is used to make some design, that is equipments. It is used to design some equipments. So with the help of that angle of repose only, we can design some equipments which are used. Here you can see, that is, it may be used to design an appropriate hopper or a silo to store the material, or to size a conveyor belt for transporting the material. So these are what? Application of angle of repose. Okay, so angle of friction is over, angle of repose is over, which are related here. Okay. Next point. See here, the next point is circular motion. So in the from lower class, you people are studying regarding the circular motion. What do you mean by circular motion? What are the examples of circular motion? See here, students, a motion can be divided into four types. We can consider either it is rectilinear motion. Rectilinear motion means what? This is a straight line motion, right? Rectilinear motion we can say. Then we have vibrational motion. Okay, that is to and fro motion is called as vibrational motion, right? Then we have a circular motion. Circular motion means what? The body is moving along the circumference of the circle, then it is called as what? Circular motion. Okay. Rotatory motion, this is also, we can say it as a rotatory motion. So there are many types of motion. Here we have a circular motion. So what do you mean by circular motion? See here, the motion of a body in a circular path is known as circular motion. So simple definition, if the motion of a body is along the circular path, so here you can see the example, that is, if the object is moving along the circular path. So this is one circular path. If the object is moving along this path, then it is called as what? Circular motion. So when a particle or any body is moving in a circular path, its direction of motion at any instant is along the tangent of the circle at that instant. Means here, when the object, suppose here, if you are standing at the center, or you are you tied a stone to the thread, if you are reeling it over a circular path, if you are reeling it over a circular path, always, suppose, just assume that, suppose the thread cuts here, suppose the thread cuts here, if the whatever the ball or the stone is there, if it is moving, it will cut and it will move along the tangent. It will move along the tangent. So that is called as tangential motion of the object when it is in a circular path. So here what they want to say is, if the objects are moving in a circular path, the motion of the body will be along the tangent. Means if the body is here, then the motion is along the tangent. If the body is here, the motion is along this direction. This direction means, in short, if the object is in a circular path, then here what happens? Its motion is along the tangent. Okay, it means that the direction of motion of the body, which is moving in a circle, it changes continuously. It changes continuously. Means if the object is moving in a circular path, its path or its direction of motion always changing, always changing. Okay, so when the motion is changing, when the direction of motion is changing, what we need to understand, as we know that when direction and magnitude both are changing for a body when it is in motion, it means that its velocity is changing. Its velocity is changing. Therefore, the body will get accelerated. Are you getting my point? That is, see here students, which means that what I told you, the body is in the circular motion. So when the body is in the circular motion, the motion or the velocity is along the tangent. The velocity is along what? Tangent of the circular path. Like this it will be. Okay. So when the direction, you can see here, when the object is at this point, the direction is here, the object is here, the direction is here, the object is here, the direction is here. So you can see at each and every point, the direction of motion is changing. So when the direction of motion is changing, what we can say, the velocity is changing for a body. So when velocity is changing for a body, we can say that the body is getting accelerated. The body is getting what? Accelerated. So here, whatever the acceleration is associated with the body, such acceleration is called as centripetal acceleration. Such an acceleration is called as what? Centripetal. Sorry. Such acceleration is called as what? Centripetal acceleration. So I'll repeat. In a circular motion, when the body is moving, its velocity is changing continuously. So when the velocity is changing continuously, the body is getting accelerated. So when the body is getting accelerated, it's a that is, it is called as centripetal acceleration. And the force which is acting on a body in the circular path is called as what? Our next point, that is centripetal force. So here students, what do you mean by centripetal force? Centripetal force in the sense, if the body is moving in a circular path, here's some force which is acting towards the center. Some force which is acting towards the center. So such a force is called as what? Centripetal force. So in a circular motion, we can learn three basic definitions. One is centripetal force, which means that the force which is acting towards the center of the circle, that is called as centripetal force. Centripetal acceleration means when the body is moving in a circular path with which the acceleration it is moving, it is called as centripetal acceleration. So the centripetal force is given by mv square divided by R. We just need to remember the formula. The centripetal force is given by what? mv square divided by R here, right? Okay, then next. So here, as we know that one point we know from the previous chapter, the relation between linear velocity v, the relation between the linear velocity v and the angular velocity omega. So I hope you know that the relation between them, it is given by v is equal to r into omega. Right. So here what we have expression, the centripetal force F is equal to mv square. It is mv square divided by 2. So what I'll do now, I'll just substitute the value of V here. So what is the value of V? V value is R into omega whole square divided by 2. So that is nothing but m R omega ka whole square it is. That it becomes R square omega square divided by R. So here it is centripetal forces m V square divided by R it is, okay. Right, so now you can see here this r will get cancelled, therefore I am getting it as centripetal force F is equal to mr omega square, where m is the mass of the body, r is the radius in which path it is moving, no, that radius it is. Omega is what? Angular velocity. We know that whenever any object is in a circular path, we consider angular velocity, angular acceleration and all. So here the angular velocity is given by omega. We need to remember 2 points here, students. That is, one is what is the expression for centripetal force in terms of linear velocity as well as in terms of angular velocity. Linear velocity it is given by mv square by r, and angular velocity it is given by mr omega square. So directly by substituting the value of mass, radius and angular velocity, the centripetal force can be calculated. Then the next definition is, that is centrifugal force. Okay. So before going for the centrifugal force, here we learned one more point, that is centripetal acceleration. So we don't have a derivation directly, means from the last chapter, you know the derivation of centripetal acceleration. The centripetal acceleration is given by, it is v square divided by r. It is v square divided by r here, where v is the velocity, r is the radius, or else you can substitute again, that is the value of v. So what is the value of v? V value is given by v is equal to r omega. So it becomes r omega by r, its whole square. Therefore it becomes what? R into omega square. Means in terms of linear velocity also we can write, in terms of angular velocity also we can write it. So centripetal force is mv square by r or mr omega square. Centripetal acceleration is v square divided by r. That's it. Then our next term is centrifugal force. What is centrifugal force? Let us see. Centrifugal force, a force that arises when a body is moving actually along the circular path by virtue of tendency of the body to regain its natural straight line path. Means here what happens when you leave that, okay? So suppose if you have a stone tied to the thread, if you are rolling it, you may experience some outward force also. So in simple language, such outward force is called as what? Centrifugal force. Or you can take an example, that is when a bus is negotiating a sharp curve, the passengers in the bus are deflected from the positions to the outward side, that is away from the center of the circular road. The force which is responsible for the deflection or the movement of passengers from their position is known as what? Centrifugal force. It is known as what? Centrifugal force. Thus, a force that tends to move the bodies or particles of a rotating frame away from the axis of rotation is called as what? Centrifugal force. So the centrifugal force is nothing but what? When a body is in a rotating motion or a rotational motion, some outward force is acting, that is called as centrifugal force. So here the magnitude of the centripetal force and the centrifugal force both are equal. We say that the magnitude of centripetal and centrifugal force are both are equal only, but it is in the opposite direction. Okay, therefore we can also take the expression for centrifugal force as mv square divided by r itself. Mv square divided by r. See here students, I told you this is whatever our relation between linear velocity and angular velocity is there, we can write this expression, that is mv square by r and mr omega square. We can also substitute omega is equal to 2 pi divided by t. Do you know this? That is, this angular velocity is given by, actually we can take it as omega is equal to 2 pi f also. So this f is nothing but what? F is nothing but the reciprocal of time period. So by this we can also write omega is equal to 2 pi divided by t. Therefore, see our expression F is equal to centripetal force is equal to, here these are the two equations. One is in terms of linear velocity radius and one more is in terms of radius and angular velocity. Now you can see in terms of time period, it becomes m into r into omega square, that is 2 pi divided by t whole square. This is equal to m r 4 pi square divided by t square. 4 pi square divided by t square, right? Or we also know that this reciprocal of time period is also called as what? Frequency. Therefore, I can also write it as what? M r into 4 pi square 1 by t square. 1 by t square is nothing but what? 1 by t is what? F. Therefore, 1 by t square is nothing but what? It is f square. In some books, you can see the frequency we take it as f, or in some book we can see that it is written as mu. Okay, that is also frequency only. So this is another formula for centripetal force in terms of time period or in terms of frequency. Both you can see here. Okay. So here, what is the summary? What we can say is the difference between centripetal and centrifugal force. What we can summarize, the centripetal force is directed towards the center of the circular path. Always the centripetal force is towards the center, but the centrifugal force is always away from the center. Centrifugal force is always away from the center here. Getting? So that is the first difference between centripetal and centrifugal force. One is towards the center and one more is the away from the center. Second difference what we can say is the centripetal force acts on a body when it rotates in a circular path. Okay, so the centripetal force acts when the body is in a circular path. Okay, when it is rotating in a circular path, but the centrifugal force acts on a body in a rotating frame. What is the meaning of this? I told you that is the body is moving in a circular path. Okay, I'll just explain you this one. See here, for example, if the body is in the circular path, when it is in a circular path, here the centripetal force will act. So now centrifugal force is what? Here it is away from the center, one point, and when it is rotating, it means suppose the thread, whatever the thread is there, suppose if it cuts, here the body will move along this direction. So when it is moving along this direction, in this frame also the centrifugal force will be acting. That time the centripetal force will not be there, but the centrifugal force will be there. Then the next main difference we can say is the centripetal force is a real force, students. Always you remember that the centripetal force is a real force which you can observe, means you can experience this one. But the centrifugal force is an pseudo force. We say it as a pseudo force. Okay, so in the next coming classes we can see what is a pseudo force. Okay, so remember the centripetal force is a real force, centrifugal force is a pseudo force. The next is centripetal force is needed for circular motion of a body. Always the centripetal forces must and should when the bodies are in circular motion. Then centrifugal force is not needed for the circular motion of the body. Okay, so this automatically it is come to an existence that a centrifugal force is not so necessary if the bodies are in a circular path, but centripetal force must and should be there only. The centripetal force comes into play in both inertial and non-inertial frame of reference. So I hope you studied the frame of references. We have two types of frame of references, that is inertial and non-inertial frame of references. So the centripetal force comes under both inertial and non-inertial, but the centrifugal force comes into play in an non-inertial frame of reference. So this is the main difference between the centripetal and the centrifugal force. So remember this so that in MCQs directly we can understand. So they may ask you, like they may give you which is a pseudo force. The four options will be there, like centripetal force, gravitational force, centrifugal force, nuclear force. So the correct option is what? Centrifugal force. So like this we need to remember. Next, that is banking of roads. Next 2 point we have, that is banking of roads. So what do you mean by banking of roads? Let us see. Here banking of road is nothing but why it is necessary. What do you mean by banking of road? See that banking of road is defined as the phenomena in which the edges are raised for the curved roads above the inner edge to provide the necessary centripetal force to the vehicles so that they take a safe turn. If any vehicles are taking a turn, here you can see that in the curved road, in the turning, the edges are provided with the necessary centripetal force. Here, that is nothing but what? Banking of roads. Okay, that is nothing but what? Banking of roads. Or we can, in simple language, what we can say is the outer edge of the road is raised little above the inner edge. So you next time, suppose if you are not observed, next time whenever you are traveling in a curved section, you can observe that compared to the inner edge, the outer edge is little raised. The outer edges are little raised. So why it is raised? Because of to achieve the necessary centripetal force for the vehicle to have the safe turning, So that is nothing but what? Banking of road. Here you can see in the picture. See this one. Correct? You can see here. So some forces are there, components with that we'll discuss. Just see this one point. Right. Another terms which we are using in that is banked turn, which is defined as the turn or a change of direction in which the vehicle inclines towards inside. The angle at which the vehicle is inclined is defined as banking of angle. In simple terms, we say it as banking of angles. Okay. Okay, students, what is this banking of road or banking of angle? Why it is necessary here when during the curving to have the safe journey, this banking of roads are made. Banking of roads are made here. Okay. Then next. I told you regarding this figure, we will see some explanation part. So this is the figure where you can see that compared to the inner edge, the outer edges are little raised to have the safe kerning. See here, you can see the components. That is downward, whatever the force is acting, that is mg. That is nothing but what? That is the weight of the car which is acting in the downward direction. So you can resolve the normal force. As you know that the normal force which is acting in the upward direction, we can resolve it into two components. Here in the picture, you can see this. See here. So this red line, what you are seeing now, this is your normal force. This is your normal force. We can resolve this normal force into two components. One is cos theta and one more is sin theta. So this is n cos theta and n sin theta are the angles made. These are the angles made by the normal force, or the components made by the normal force. Okay. Here, what is the expression for speed of a body when it is on a curved road? Okay, we can see on a curved or a banked circular road, what is the expression? Means what speed the body should achieve so that it can take a safe turn. So here we will not see the derivation part, just we will see the final expression. What is the expression for that speed so that the body will take a safe turn? That is v is equal to rg tan theta to the power of 1 by 2, or we can take it as under root of rg tan theta. Okay, which means that if the if the vehicles are moving with this speed, it will take a safe turn. R is the radius, G is acceleration due to gravity. Here theta, you can see in the figure, the theta, the angle between that inclined and the horizontal plane here, that is r, g and tan theta. So suppose if you substitute all these values, whatever the speed is required, with that speed the vehicle should move so that it will take a safe turn on a banked road, right? Here always on an object two forces will be acting. One is normal force and the other one is the weight which is acting in the downward direction. So the normal force is divided into two components, n cos theta and n sin theta, right? So this speed is required so that the vehicle will take the safe turn. V is equal to rg tan theta to the power of 1 by 2 or root of this. So derivation part is not important, only the equation is important for our question solving, right students? So here this completes the laws of motion synopsis. So if this part is clear, then whatever our MCQs will be there, that will be easy for us to understand, right? Here one more application based question what we can see is last point, that is here this expression what I have given you, that is v is equal to root of rg tan theta. This is what when the vehicles are on a banked smooth circular road, this speed is enough. If the vehicles are negotiate a banked rough circular road, if it is on a rough circular road, then we can take one more example. So you need to understand the questions clearly so that the solving part will be easy. That is v is equal to square bracket rg into bracket tan theta plus mu bracket completes divided by this whole divided by 1 minus mu tan theta raised to 1 by 2. So this is what, this is the speed of the vehicles when it is in a curved or a banked rough circular path. So above expression is for what? For a smooth surface, and the below expression is for what? It is for a curved surface. So I hope this question and this synopsis, it is clear to you that what we need to remember, that is Newton's laws. After Newton's laws, example for Newton's laws we have seen in detail. Then next inertia, this three laws, Newton's three laws are there. The first law is called as what? Law of inertia. So there we come across three types of inertia: inertia of rest, motion, then direction. Example we have seen there in detail. Then after Newton's laws, we discussed momentum concept, law of conservation of momentum. Then what happens to the body when it is in a lift? Four different cases we studied. The next point, friction. how to reduce it, application, disadvantages and all. Then banking of road, why the banking of road is not required. These all concepts we discussed in this chapter. So in the next class onwards, we can directly go for the MCQs. So we will see the previous few years NEET questions and few more application based questions so that the upcoming exams will be easy for you. Okay, students. Thank you. Thank you for watching.